All right, so in this video, I'm going to model the signal box, this little project by Herzog Meuron in Grasshopper for Rhino. And I'll show you how to get the kind of twisted strip geometry that you see there, and it's making that cool gradient effect. So what we want to do is start in Rhino by modeling a box. We're going to model kind of a volume that's pretty close to what the size of that in proportion to that guy is. And the other thing that we'll do is we're going to grab one of these edges and kind of scale it back to give it. There's one face of the box that's like a little bit twisted. You can see in the images. All right, so we're going to start with that geometry. The other thing that we want to do, I think, is we're going to kind of trim away the surfaces into the segments that we actually have twisting on. So we're just kind of working with the parts that are twisting there. So first thing I'll do is I'll explode this poly surface into individual faces. And then I think there's actually, I'm not 100% sure all the faces. I mean, we got the twisted faces kind of have a lot. And then there's that kind of one skinny side. Looks like the other skinny side has most of its face. So let's use a cut plane to do this. So I'll type in cut plane. I'm going to choose 3-point. And then I'll click and just draw kind of a plane. So we can use that to define kind of this top. I think they're all pretty much aligned at the top. And that up just a bit. And then I'll copy this guy. It seems like this one is just there. And so let's say this one's kind of like a little bit lower. And finally, the two larger sides, have most of their face is this kind of twisted thing. Let's delete those planes. So these are the segments that we're going to be operating on. All right, so I'm going to open up Grasshopper. The first thing I want to do is I'm just going to do one surface at a time, but I want to reference this surface into Grasshopper. I'll go to the Parameters tab, Geometry, go to Surface. And if I right-click on that, go to Set One Surface, I can use that as a reference now in Grasshopper. And I can also hide the base surface so that not getting in my way. All right, now what I want to do is kind of subdivide that into strips. So I'll go to Surface tab, go to Utilities, and get this component called Isotrim. Isotrim allows us to divide up a surface into smaller subsurfaces. It requires two inputs. One of them is the base surface, that's that guy, and the other one is it's called a domain. And basically, the component that it's looking for is, if we go to Math, under Domain, this divide domain to component. And what this will do is we'll give it like a subdivision value in the UV direction. So if I make a number slider, I can do just by double-clicking on the canvas and plug those guys in. Oh yeah, so I was wondering if this would happen. So because our surface is actually a trimmed surface, it's kind of like untrimming itself when we do our subsurface. So we actually need to kind of remodel these surfaces here. So I'm going to do this one real quick so we can work from it. So I'm just going to make a new surface that isn't trimmed, that fits inside that space. So now we right click, set one surface on that guy, you can see it's not like going past those edges. All right, so basically this controls how many subdivisions we have in each direction. You can see as I move my slider around. If I set that to 1, that means I only have horizontal subdivisions, and this obviously affects the spacing of those. I'm going to double click on that slider and make it a higher number. Kind of more like the skinny strips you see on the building. Cool, all right. And so now we've kind of divided it into strips. I'll unpreview this stuff. And what we would need to do next is actually do the kind of twisting operation on that geometry. So what we're going to need is first of all, we're going to need something to rotate it around. So what I want to do is use one of the edges of each of the faces of these strips. So to get the edges of each of our subsurfaces, we'll go to surface. I think it's the analysis and brep edges. So brep edges is going to give us like, the edges of each of our subsurfaces, and they're all going to come out of the EN component, which means naked edges, which means they're like, if we had a poly surface and it had some joined edges between joined faces, that would be our interiors, but we just have naked edges. So the other thing that you'll notice, and I'll go to parameters and get a panel, is there are obviously there's 4 lines that represent each of those faces, but it's also it's kind of reformatted our data here. So if you'll also notice, that's the first time we're seeing this kind of dash line. What that means is we have what's called grafted data, and it's putting each of our lines, each of the 4 lines for one surface, into like a branch. It's called a branch of data. So each of these like grayer sets of numbers here like represents one of the strips, and then each of the 4 lines in that list represent one of the 4 edges. So the benefit of this is that we can select these are in a certain order, 0, 1, 2, 3, so we can select all of like item number 0 from every list. And in order to do that, I'll go to sets, list, and list item. The list item requires a list, and it requires what's called an index. Index is the same as these 4 numbers you see on the side of each list. Just means, where is that item that we want in the list that we are pulling it from. So I'll make a number slider. So let's see, 0. All right, so we can see that edge is kind of like the top edge of each surface. 1's obviously the right side. Made this a little more. And then that's the bottom, and that's the right. So we actually want 0, which is the top edge. So you can see when you look at the project that it's actually twisting like against the top edge. Like the top edge stays straight, and then the whole strip kind of folds up from there. So that's going to be like our rotation axis. The next thing we want to establish is like a number of kind of curved segments that are on the face of the surface that we can actually rotate to get this kind of twisting shape to happen. So if I go to back to surface, utility, or analysis. I don't know where it is, but what I'm looking for is a component. So I'll double click on the canvas to just search for it, called ISO curve. So this, just like the extract ISO curve command in Rhino, will extract like lines on a surface depending on a UV address or location. So we need to tell it like where we want to extract these curves. So to do that, we're going to get what's called an MD slider, a multi-dimensional slider. Under parameters, input, there it is. And this guy is going to help us like select. So like our UV is like a UV address. Like before, when we divide the surface this direction, that's in the U direction, right? That's one kind of like dimension of our surface, and this is the other. So what I need to do is give it like a dimension, an address, a UV address, where I want a curve on that surface to come from. If I plug that in there, I'm also going to right-click on the S input and hit reparameterize. Now you can see it's giving me a line on each surface, depending where I place this little slider. And if I get the parameters, geometry, get a curve. So it's giving me like a curve in each direction. Obviously that's the U direction there, and then the V direction. We just need the V direction ones, but yeah, you can see that's kind of giving us the curve in that direction. All right, so what we want to do basically is get like 4 curves. And I'm actually just going to do this to keep things simple. I'm going to copy this whole thing 4 times. And the first one we actually want to be right at the end there. So we'll use that curve, set it to 0 in this dimension. Doesn't matter what it is in the U dimension. So I'm just going to select it all, hit Control-C, Control-V on my keyboard. And I'll set it to like 0.2 or something like that. Then I'll do like the opposite end if we're dealing with a range of 0 to 1, so 0.8. And then I'll do 1. So now we're going more like from one end to the other on our surface here. We've got 4 curves. And what we need to do next is rotate them around our rotation axes. So if I go to the Transform tab under Euclidean, it's a couple different rotate options. I'm going to use the rotate around an axis. And this guy requires whatever the geometry is we want to rotate. That's our, we actually just need to rotate the 2 center curves, right? It needs an angle. Let's give it a number. Now remember, by default, angles in Grasshopper are in radians, so we want to right-click and hit degrees to translate into degrees there. And then we need a rotation axis, which is our curve that we selected up here. And it's not quite doing what I would expect. Oh, I see, it's rotating inward. So in order to fix that, we're just going to make this a negative number instead of a positive number. So go to math, there's a quick operator for this. Where we just hit negative. This makes whatever number you plug into it negative. All right, there we go. So now it's rotating outwards. All right, and then I'll copy paste this as well. Oops. And so now that guy's rotating. We're just going to keep the same number slide. Same. Sweet. And now all we need to do is loft each of these 4 curves together. And I'll go to Surface, click Freeform and Loft. Now in Grasshopper, you can plug multiple inputs into an item. So if I drag from my first curve there, and I want to plug this one in as well, I'm going to hold Shift, and you can see my little cursor giving me like a green arrow. Now it's also just like it's important the order in which you select curves when you loft stuff in Rhino. It's also important the order that I plug them into this component here. If I were to plug this one in now, you can see it's actually going like from one end back to the other, back to one of these other curves. So we don't want that, obviously. So keep in mind to plug them in the right order. There you have it. So that's these are our strips. We can kind of change how open or closed they are. And we can also change like where it starts and stops curving, obviously, by sliding this. You can kind of fine tune how that looks. All right, cool. So yeah, that's kind of how to model the strips on the signal box in a really simple way using Grasshopper. I'm going to end the video there.